Good morning, chaps. So, the grand finale of our Paints and Finishes Forum, week 4, or module 4. It's not quite gone in that order, but and today is surface prep. I hope I'm correct.
It is.
Good stuff. Right, so let's kick off with every joiner's favourite hobby, with the big sanding question. So, why have we traditionally sanded the life out of everything in joinery products in the UK? Steve.
Good morning, everybody. And this is a little bit of Steve Ashton's opinion, but back in the late 70s when I did my apprenticeship, it was just one of those aspects of assembling joinery that you got involved in sanding. And there was a great big drum sander there and hand orbital sanders of their day, and everything got sanded. But it was only when I got into the coatings industry that I started to question the reasons why. And my belief is that we've always sanded because of tooling quality, the machining of the surface, the substrate instability, the way that we change from air-dried timbers to kiln-dried timbers, which were a lot drier and therefore more unstable, and the flush joint detail. And so if you put all those together, an unstable material in an environment that was being heated and warmed and therefore drawing moisture from the substrate, we create instability. And from the machining process on the tensioner and the mortise to the assembly, we got differential step in the joint, which we then sanded the hell out of, even to the point that we started surface thicknessing with sanders. I believe that's the background, and that is something that was more noticeably seen when factory finishing started to be introduced, because the paint products disturbed the surface, and therefore you got a reaction that you noticed. It felt really smooth before that, but after the paint, we started to see the contours or the machining defects, the compression. Anything to add to that, Craig?
No, very, very similar experiences myself. You know, when I was first starting in the joinery industry, it'd be one of the first jobs the apprentice gets is they get given sandpaper and an orbital or a belt sander and told to crack on. So it's the machining quality, that the steps in the joints on the tensioner and mortiser. It could vary depending on who the machinist was at the time, and it was just a natural thing, because in the late 80s, early 90s, everything didn't tend to be factory finished in the UK. It would only be a coat of primer at best and sent out to site. So it was never recognised in the joinery manufacturer. It was only throughout the 90s, where the factory finishing started to become popular, that these sort of instances started to come to the forefront.
And I think there was a great belief at the time that you couldn't get sanding wrong. Whatever you did, as long as it felt smooth and the joint was flush when the item left the joinery workshop, then you'd done your job. But again, in this conversation and presentation, we'll talk about different grit sizes and the effect and impact that they have. So that's the background to this presentation.
I've got one different take on that. Why people sand, and I went, just a very quick story. I went to I won't name and shame him, but I talked to him about lights. But back before Lignum was invented, before we had the joinery network, and I was telling him about the finish on the lights tool. And I asked him how when you're producing joinery, how much time are you spending sanding? And he said, hours, days, like a ridiculous amount of time. I said, well, if you use the correct tooling that gives you that finish, where you've actually machined the timber, you'll have zero or minimal sanding to do. One, he didn't believe me, and then when we got over the fact that I was actually telling the truth, his answer was, "But my boys love sanding." So I say no more. Anyway, so we'll go on to some sort of frequently asked sort of questions in the industry. I'm getting raised grain effect in sections on engineered softwood visible after the first coat. Craig.
So there's a number of reasons why this can happen. So we've got some example pictures, if you wouldn't mind bringing them up, Luke. So
Let's have a go.
These sort of pictures or examples are quite common throughout joinery companies up and down the UK that use laminated softwoods and hardwoods for that matter. And there's a number of reasons why these sort of things can happen. So we can see here on the on this picture that you can see the undulations of the grain of the timber. Now, a lot of people consider this to be absolutely fine. It's not a problem, because they're selling timber windows. But every now and again, it comes to the forefront that it goes a little bit beyond what we can see here, and then it looks more like a defect. What we've got to understand is the reasons behind these sort of what happens, and one of them is compression of the surface of the timber when machining. Now, it's not always the fault of the joinery manufacturer. This compression can happen at source of timber. So if we just move to the next one, Luke.
Sure. Not that one?
Yep. So we can see here, again, we've got some machining defects. We can see the straight lines of the cutters that obviously been affected. But if we move on to the next one, so we can, it's the magnification that, go again.
This one.
There we go. Okay, so what we're looking at here is a crosscut through the end grain of timber. So we're looking at the surface of the timber that we're working with. And you can see all the cell structures there all nicely. And as we move to the surface of the timber, you can see how collapsed them cell structures have become. And what's happened there is we've created that, either with blunt or inadequate tooling. So they're instead of cutting through the surface of the timber, we're pinching that top layer. But this could also happen at source in the mill. So if our cutters are sharp, and then when we put a coat of primer on, we see that little nick in the timber, which we've just seen on a previous photo, that could actually be from the timber manufacturer who's put the laminated sections together, because they're not looking at the surface finish that we've got to create afterwards. And what will happen is these cell structures, although they're squashed tightly now, when we introduce moisture, i.e. your first coat of primer, they will expand and give us the undulations that we're seeing.
Okay, next picture.
Yep. So we can see here, it's quite likely that these surface imperfections were not visible prior to paint. So if they're not visible, then if they're not visible prior to paint, then that gives us an indication that they've happened at source. So what we must take into account is when we machine the timbers, we're taking off enough timber from the supplier that we get rid of that pinching effect. It can also be an issue with, it may not be purely the primer that we're putting on, that obviously we're applying water that holds tight to the surface of the timber, but with the gluing and the manufacturing process of the laminated sections, they do like to dry it a little bit more so than what regular kiln dry timber. And then what we're looking at there under magnification is a better surface cut of the timber. We've got no pinching effect of the cell structure. So we're not going to get any raised grain areas on the timber.
Just as going back to the point that Craig made, it's a nice picture. just going back to the point that Craig made about moisture content, it's an interesting detail to understand, because as we see more engineered and laminated products coming onto the market, particularly in modified heat treated timbers, as well as the chemically modified, but particularly the heat treated, we're seeing very low moisture contents. On the modified timber, that's not an issue because it's part of their characteristics. But on standard common timbers, they are taking that timber down to 10%. And therefore it becomes very dry. And that is for the gluing lamination process. It then is being exposed to external climate conditions going up to anywhere around 18%. So there's a huge differential movement of 3 to 4%. And therefore that has another impact on the joinery and what you see through the coating. The coating is just following the contours that are on the surface of the substrate. So again, you've heard me say this before, it's a bit like a barometer, that it's giving you an indicator. Did it happen with solvent paints? No, it didn't, because they don't react in the same way. But water-based paints have showed their performance characteristics over 20 to 30 years, and they're with us to stay. So we have to understand the partnership and the effect of the substrate to begin with.
Excellent. So what is the preferred surface scenario preparation prior to painting?
So preferably a good machined finish. And what we mean by that is a cleaned finish that isn't pinching the surface. It's a tight finish that the coating doesn't disrupt or get reaction from. And in general terms, the types of tooling that Lights will be talking to you quite soon in another presentation are what we see as coating suppliers give best performance and also reduced cost, because you're taking a big part of the sanding out. You may not be able to get rid of sanding completely, but if you can reduce that work level, you're saving the company money, but you're also achieving the finishes that the coating companies recommend. So a nice machine finish. And again, if you're buying stock, so if we look at the sash in the pictures, we'll be machining the rebate profile, the stormproof profile, but we might not be touching the faces. And they're the two that we see both internally and externally. So by remachining those or oversizing your sections to skim them, then that could be best practice to reduce the amount of sanding you do. The other thing that sanding does, particularly if you're drum sanding, is you're removing the V joint and the soft rounds that are part of the tooling that give you performance by design. If you reduce that soft round on the edges from a 3mm radius to a 2mm radius, you in turn reduce the coating performance.
Sure.
Yeah. So what we're trying to say is the paints do not need a sanded timber surface to work, to perform well. The sanding is inherent, it's a distinct characteristic of the UK joinery manufacturing. That the tooling is, or we're well versed on sanding everything, and we're still in that cycle. That the sanding is not necessary if the surface is prepared properly, and if we the correct tooling and the correct profiles, with V joints, then sanding is very much not required.
Okay, and do we need to tweak any surface prep, excuse me, according to the type of timbers that we're using?
In essence, yes, we should understand what type of timber we're using and the type of preparation that's required. So each joinery manufacturer is going to be different, but essentially, if we're preparing a piece of Accoya for paint, and we're preparing a piece of laminated softwood for painting, then we shouldn't be treating the two timbers exactly the same.
And if the joiner, sorry, Craig, to interrupt you, if the joiner needs advice on that, who should they be talking to? Should it be the tooling manufacturer, the timber supplier, or the finishers guys? I'm assuming you guys are probably best placed, but
yeah, it's everyone. Not the more knowledge people have, is the better decisions they're going to make. And that's when the processes are going to improve. But we know for a fact that there's going to be very little grain lift when a company is using Accoya, for example. So the preparation should reflect that it should be less preparation. But then we should also understand that the preparation on something like Accoya, where it's quite a wide grain timber, that there'll be lots of summer growth that can be affected how we sand. So if we're sanding using soft pad orbital sanders, then we're going to eat into that summer growth more than the winter growth and create undulations ourselves.
We saw the same thing with Douglas fir when that was predominant in the market, because again it's a very wide grain, broad product. With the density difference is quite substantial, and so the first thing that anybody does with an orbital sander is, if there's a small defect, they touch the edge of the orbital sander and push it in there to get rid of the defect. And as you're doing that motion, the push motion and the edge takes this softer material away, and you don't see that when you're doing it. You only see it when it's a visual contour under the coating.
Sure. Okay, and to save sanding the living daylights out of it, what grit sandpaper is recommended for surface finish prep?
In general, we would have to have the conversation about the methodology. As Craig said, there is so many different processes of sanding these days, from sanding manually, orbitally, or you've got your drum sanders, or you've got your fladding machines. So we can expand the conversation, but in general terms of sandpaper, we're talking anything between 120 to 240 in finishing terms. Your front belt on your drum sander might be a little bit more coarse than that, just because of the work that you're doing. But the more coarse the grit, the more it will tear the surface. And of course, if you're putting a sash or a door through a drum sander, then at some point you're cross sanding, and that usually is the rails, the mid rail, bottom rail and top rail. And what happens then? It comes out of the sander, and then you put it on the bench and you do some more sanding with the orbital to get rid of the cross sanding. And so one has a knock-on effect to the next. And so if you're looking for the solution, work back and remove sanding from your process if you possibly can. You can use too finer grits because you can polish the surface, and then you get a reaction again from the coatings because it feels really smooth, but in effect you haven't created the right surface. So we're pretty versed in the industry of what is best practice when sanding is necessary, and the advice is readily there, either through the coating companies or the equipment suppliers, etc.
Cool. And what about the different sort of grits between prep and denibbing, the denibbing process between coats? Is there a go-to for that?
Yeah, so it's really important to understand that denibbing is not sanding. So we are trying to just remove any surface fibers that have raised during the coating process. If we are looking at defects in the timber that need prepping after, then that's a different, that's a different conversation. But denibbing is with finer sandpapers. Probably, if people want a point to work to, probably about a 240 grit, the soft pad sanders. So the sponge backs like Steve's got there. So
It's just a sample.
The
Fine,
denibbing
Steve Ashton sample.
So the denibbing pads are what we need. So if we've got everything correct in the processes, that's all that is required. And again, we're not sanding, we're just denibbing.
Yeah, the beauty of these pads is if you look at the section there, they will easily fold round the contour. So they don't create an edge that will remove the coating. And denibbing is also, for me, a quality control. If you watch anybody do it, they'll be sanding with that and then feeling with the other hand. So it gives you an opportunity to lightly prep the surface. The coatings don't actually need denibbing in the factory finishing stage. It just becomes a quality control. So you're creating the best finish. The other reason why denibbing is good, particularly between the mid coat and the top coat, is because if you have furring at that stage, they will protrude through the coating system. And the nearer that fur is to the top of the surface of the coating, the weaker the coating is, because it is your moisture transfer point. You like putting a conduit in there for water to travel to the surface of the substrate. So if you're denibbing, you're removing the nib, and therefore you've got a uniform homogeneous coating, which becomes a higher performer.
So would your recommendation be, if you had to standardize, to denib between the second and third coat, or the first and second, or both?
Yeah, for me, that's it's a purely personal choice. How it works in practice.
You're not a politician, are you, Craig? In a different.
I am, yeah, but I'm always one for, if somebody wants my advice, I always go after the second coat before the last coat, because that is, you only want to be denibbing once anyway in the process. The coatings that you use do not need sanding between coats to adhere to each other during standard practices. Only if you've left them for a period of time will they fully cure, and then they need an actual key. But if they, standard practices for coating, the coatings do not need to be sanded together. They're only, it's only there as a QC check. So my QC check would always be after the second coat.
Yeah. And then we add a few things in there. So if it's a translucent base stain and I've got furring on the first coat, if I denib, I'll push them down and they'll flick back up. If it's the mid coat, and particularly the top coats, because they're tougher surfaces, you will remove the nib and they won't come back. So in terms of process control and your good machining, no denibbing, just slight defects, then in a 3-coat system, between 2 and 3 is where you would spend the time denibbing.
Perfect. Okay. Thank you very much, chaps. We've got, I think, Jed next week with more machining practices and about timbers, and it sort of comes on nicely after this one. So yeah, watch this space. We'll go back to the floor and take any questions.